All right, for the next few minutes, we're going to pull back the curtain on digital security. We're talking about the keys, the secret codes, and yeah, even the laws that are supposed to protect your data. The goal here is to help you go from just being a user of the internet to someone who's actually empowered. So let's jump right in.
First things first, let's get personal. I want you to think for a second, how secure is your password? Come on, be honest. Are you using your kid's birthday or the classic password 123? Because you got to remember that one little string of characters is often the only thing standing between all your private stuff and, well, the rest of the world.
Now look at this. This chart shows just how dramatically the game changes when you add a little bit of complexity. See that 8-character password with only numbers? A hacker can crack that instantly. Poof, they're in. But if you just add different types of characters to that same password, suddenly it takes 39 minutes. Now watch this. Jump to a 12-character password with all the bells and whistles, uppercase, lowercase, numbers, symbols, and a hacker would need 3,000 years. This makes one thing crystal clear. Length and variety are everything.
And that really brings us to our first big idea. You can think of every weak password you have as its own little ticking clock. It's basically a race between you and some automated hacking tool out there. And the simpler your password, the shorter that race is going to be.
Well, the good news is, this is a race you can absolutely win. And you don't have to be some kind of genius hacker to do it. It's really just about making it so annoying and time-consuming to crack your password that any hacker is just going to give up and move on to an easier target.
So, let's talk about building your defense. A strong password, that's the cornerstone of your entire digital fortress. It's the front gate, right? It's the first and honestly the most critical layer of protection that you have direct control over.
So what does a strong password actually look like? Well, here are the absolute minimum requirements. It's got to be at least 8 characters long, although, as we just saw, 12 or more is way, way better. It can't have your name in it, obviously. And this is the big one. You have to mix it up. Use a combo of at least 3 of these 4 categories: uppercase letters, lowercase letters, numbers, and symbols. Seriously, this isn't just a friendly suggestion. It's the absolute baseline for having a decent lock on your digital door.
Okay, so let's say your accounts are locked down. Great. But that only protects your data when it's just sitting there. What about when you send it across the internet? You know, emails, messages, your credit card info when you buy something. To protect that, we need something called encryption. It's basically the art of sending a secret in plain sight.
Let's start with the simplest version. It's called symmetric encryption. The easiest way to think about this is like your house key. You use the exact same key to lock your door when you leave and to unlock it when you get home. It's simple, it's fast, and it works perfectly, as long as only you and the people you trust have a copy of that key.
But right away, you see the big problem, right? For the person on the other end to unlock your message, they need the exact same secret key. So how do you get them that key securely in the first place? If you just send it over the internet, anyone could grab it. It's a classic chicken and egg problem. If a snooper intercepts the key, they can read every single thing you send. This is called the key exchange problem, and it's a huge deal.
Now, the solution to that problem is this really clever method called asymmetric encryption. The best analogy for this is a special kind of mailbox. You have a mail slot, that's your public key, and you can give that out to literally everyone. Anyone can drop a letter in, but only you have the unique private key that can actually open the mailbox and read what's inside.
So here's how that works. A sender takes your public key, that open mail slot, and uses it to lock their message. They can get this key from anywhere, it doesn't matter, it's not a secret. But here's the magic. Once that message is locked with the public key, it can only be unlocked by the one person who has the matching private key. This totally solves that key exchange problem we were just talking about.
So, let's recap. We've got 2 systems here. On one hand, symmetric encryption is super fast and efficient, but it has that big security hole when it comes to sharing the key. On the other hand, asymmetric encryption is incredibly secure for sharing keys, but it's much, much slower and takes a ton of computing power. So it kind of seems like you have to pick one, speed or security.
Or do you? This is where modern digital security gets really, really smart. What if you could use that slow, super secure method for just one tiny, crucial moment, and then use the fast, efficient method for everything else?
And that, right there, is the genius of what's called hybrid encryption. It's a system that secures pretty much the entire modern internet. It combines the 2 methods we just talked about, taking the best part from each one. It uses that slow, super secure asymmetric method for one tiny job, to safely deliver a temporary secret key.
And then it uses that key with the fast, symmetric method for the rest of the conversation. Okay, let's walk through it step by step. First, your computer creates a random, one-time use session key. Then, and this is the clever part, it encrypts that key using the receiver's public key. That's the slow but secure step. Third, it sends that tiny little encrypted package over the internet. Fourth, the receiver uses their unique private key to unlock the session key. And boom, now both sides have the exact same secret key and they can start talking quickly and securely using the fast method. It is, quite literally, the best of both worlds.
Now, having strong keys and secret codes is absolutely essential. But believe it or not, that's only half the story. The other half is all about legal protection. Because you see, technology can secure your data, but it's the laws that are supposed to hold companies accountable for how they actually use it.
And the biggest legal framework in this space is the GDPR. At its heart, it's really all about giving you, the individual, control. It forces companies to do things like data minimization, which just means they can only collect the data that's absolutely necessary, and purpose limitation, meaning they can only use your data for the specific reason they told you they were collecting it in the first place.
So, keeping those ideas in mind, let's do a little pop quiz. Here is a prototype of a contact form you might see on a website. Take a look. Can you spot the potential GDPR violations?
Okay, take a close look at this thing. You've got fields for name, email, phone number, and a comment box. Pay attention to the website address up top and definitely look at those little checkboxes at the bottom. What's jumping out at you? What feels wrong here? I'll give you a second.
All right, time's up. Let's go through the errors. First off, look at the URL. It says HTTP, not the secure HTTPS. That's a huge no-no. It means any data you type in is being sent as plain text for anyone to see. Second, why do they need a phone number for a simple contact form? They probably don't. That's a violation of data minimization. And third, look at those pre-checked boxes for marketing emails. Under GDPR, you have to actively consent. You can't just assume it. So that's not valid consent at all.
So, just to sum it all up, the big takeaways here are the connection has to be secure. Companies should only ask for the data they absolutely need for a specific task. They cannot use pre-check boxes to trick you into consenting, and they have to be transparent and provide a link to their privacy policy. These aren't just good ideas, they're the law in many places. So, as we wrap this up, the best way to think about your digital security is as a defense with 3 critical layers. It all starts with you, with your actions, like creating strong, unique passwords. Then it's supported by the technology, like that hybrid encryption that's working silently in the background all the time. And finally, it's enforced by the rules, the legal frameworks like GDPR, that make sure organizations handle your data the right way.
And that leaves us with one final thought to chew on. We've gone over the fundamentals of security as they are today, but in a world that's racing towards AI, quantum computing, and a future where everything is connected, what will secure even mean in 10 years? That's the question we all need to keep asking ourselves.